Hey, it's Mr. Fottrell here. Thought I'd do a quick video looking at fractals. In particular, I thought we'd look at the Koch curve. That was one of the fractals that was assigned as as an optional part of problem set 14. Just a reminder of what a fractal is. A fractal is some pattern which repeats itself over and over again, usually at smaller and smaller scales. So for example, my favorite vegetable here is Romanesco. And if you notice, it's kind of a pyramid-shaped vegetable. It's kind of like broccoli or cauliflower if you haven't had it before, seen it before. But while it's a cone-like vegetable, each part of it's actually made of several small cones. And each of those cones, if you look at them carefully, is itself made of smaller cones. And those individual little cones are made of smaller cones still, and so forth. So that pattern repeats itself over and over at smaller and smaller scales. And that's really what comprises all of fractals. And so one thing we can do in computer programming is we can we can make an iterative algorithm, an algorithm which keeps calling itself, but each time works on a smaller scale. So for example, in the homework assignment, we were looking at that Koch curve, and if we, what they recommended here was that, well, actually, if you look at the shape of it, what you've got is you've got that zeroth order Koch curve is just a line. But then what you do is this next one is actually 4 lines. And so it's like that first thing, but it's done 4 times, each time at a different angle. And if you look as you go to the next one, we're now repeating the previous shape 4 times, taking each of these line segments and turning it into another shape like that. And so we start to see this pattern of line, turn, turn, line, like that happen over and over at smaller and smaller scales. So that's really what we want to do here, is we want to make a computer program which will repeat this curve over and over at smaller scales. So let's go start writing our code. So I've got a Koch curve program here. I'll make my main method. And let's see, what we're going to need to do is use TurtleGraphics for this. And so I'll import that TurtleGraphics. And we're going to use a couple things from it. I'll just go ahead and get everything. I'll say turtlegraphics.star. One of the things the homework assignment mentioned was using that sketchpad window. So if we look back at that assignment, they said up here, if we import the TurtleGraph sketchpad window, and then we can make our new window like this. And so we'll just grab that same line of code here. So let me see if I can copy and paste this out. And I will copy that and I'll paste it into our code. Okay, and we don't have to call it whatever. We can, well, you could call it whatever. I'm going to call it window because that's really what it is. Okay, so there's our window. It's going to get a width and a height, so we need to specify what width and height we want. The purpose of this is just normally when you start a program with TurtleGraphics, it will choose kind of a default window size for you, and it's more convenient if you have a window which is the same dimensions every time, so you can really see what's happening to your drawing. And so we'll just go ahead and specify the width. I don't know, we'll start out maybe 600 wide, and we'll do a height, and maybe make that 400. Okay, oops, I need some equal signs. Okay, so that gets us our window. Let's just see how things draw on that. So I'll just do something simple. I'll take the pen and maybe put it down. Oh, I need to make a pen, don't I? So let's see, I'll say standard pen. And what we do is we pass this sketchpad window in as an argument to the pen. And so we'll have everything drawn in that window. Okay, and now we can go ahead and make that pen move. So we'll say pen.move, and I don't know, we'll move, I don't know, 100 pixels, and we'll see what it looks like. Okay, so we'll start there and just see, I don't recall right at the top exactly how our TurtleGraphics does things. Okay, so it looks like right now it's drawing our line segment going upwards. It looks like 0, 0 is in the middle of the screen, it's going upwards. So we'll have to maybe set the direction before we draw. So let's go and add that line of code in here so we can set it so it's initially facing to the right. I think that's 0 degrees. So we'll say, actually after we make the pen, but before we move, we'll say, and now if we draw, I think it'll be a line going to the right. Okay, great. And so we're ready to start drawing our curve here. Yeah, we'll start there. If we wanted, we can move this thing over to the left, but we'll come back and take care of that in just a moment. So let's go ahead and start making our method. What we'd really like to do, instead of just moving the pen, is we'd like to go draw our Koch curve. And so we'll come down here and make that new Koch method. So, and it's just going to draw, so it'll be a void method. Koch is the way I pronounce that, Koch or other pronunciations. No, skip, remind me later. So we'll give it a few parameters. In the homework assignment, let's see, it said that we should make our Koch method giving it these 1, 2, 3 parameters. So we'll tell it which iteration it is, whether it's that line, n equals 0, or whether it's got one kind of triangle in it, or whether it's got multiple ones, so forth. Those are different iterations. So we'll send in which iteration we want to draw, we'll send in the length of the line that we want to draw, and the pen that we're using. So let's go back. So we'll say int n, that's our iteration. We'll say int how many pixels we're going, they called it len, and finally we'll do our pen. Okay, so there's our method signature for it. Remember, when you're doing a recursive thing, you always need a way out. If you've got a method which is going to be calling itself, we need that base case. So let's start out with our base case. And that, I think, is probably easiest to do n equals 0. That's where you get your line. And so we'll just make the pen draw a line. So we'll just say pen dot move, and it's supposed to move this length here. Okay, so that's our base case. In other cases, we wanted to make that more interesting shape. So like if we look at that n equals 1 version of it, we need to go and draw a line, and then we need to turn 60 degrees to make that triangle. So I'm going to start making instructions to do that. So I'll draw my line. And let's see, for this one, I think we want to make them shorter and shorter. Again, if we look back at that pattern that we had, let me just go back to the homework one more time. If we look back at the pattern that we've got here, when you draw these lines, each of these lines is going to be shorter than the original thing was. And so I'm going to say, and it looks to me like each one is kind of 1/3 the length. We got a third and a third over here. This segment here would be 1/3, but instead we've gone up and down like that. So since it's an equilateral triangle, this thing here would be the same length as each of those. Okay, so we're going to go and we're going to draw a line, and then we're going to turn, I think, 60 degrees to get that equilateral, right? And then we're going to need to turn to go facing down. We need to turn like down negative 120 to go down at this angle, and then we'll turn back up 60. So that'll be our plan. So we'll move, and we'll move like length over 3, 1/3 of that length that was given for your whole curve. Okay, and then we're going to turn, and we're going to turn 60 degrees. Well, that's pen dot turn. Okay. And then we will go and move another one. And then we're going to turn again. This time we're turning back down. So we had been kind of angling upwards, and now we want to go down and turn 60 and then another 60 so that we're actually angling downwards. So we'll turn down negative 120, and we'll move another length over 3. And then now that we're angled downwards, we need to turn back up 60 to go flat at the end. So and finally move. So let's just get an idea and see if this is doing what we want. We can kind of fix things as we go. So right now, if n equals 0, we're doing that. For any other value, we're doing this. Let's see what it looks like. Okay, right now, so right now I still haven't given my main method the instructions. Let's go back and fix our main method. In my main method, I'm still just doing that. I don't want to do this anymore. Instead, I've set direction to 0. Instead, I'm going to say cook. And if I give it cook 0, I should just get a line. Oh, I need to send these 3 things. So I'll give a length. We'll make it a bit longer. So maybe we'll go like, I don't know. We made our window 600 wide. Let's make this 500 wide. Okay, and we'll send it in the pen that we made. Okay, and let's look at that one. So that's cook 0. Okay, and here's where it's kind of going off our window. So what we might want to do, it ends eventually, but maybe what we want to do is maybe start it out a little farther to the left. So let's go and move initially. So before we set our direction there, I'm going to go and just move the pen over to the left side of the window. And I can just give it 2 coordinates. And so its x coordinate, I'll say, how about negative 250? And its y coordinate will be 0. Okay, so that'll move it over there. Then I'll set the direction to be 0. So let's run that one more time. That should have our line centered in our window. So our window was 600 wide. And we're making a line that's 500 pixels long. Okay, so now we got our line centered in the window, okay? Well, let's try cook 1. So we'll do the same thing. This time we'll do cook 1 and see if that's behaving correctly. Oh, something went wrong here. Let's see. So everything else is looking good. Maybe I have to erase I don't know what happened there. Let's just double check our code and see we've done everything correctly, because it's looking really good except for that, right? Oh, you know what it was? Remember that the turtle started out in the very center of the screen and it moved to the left, and while it was moving out there, it left a line and then it came back. Okay, so we want to pick the pen up before we move. So let's go do that. This is looking pretty good otherwise. So let's see. Before we move here, because this would be drawing a line, we need to pick the pen up. So then our turtle isn't dragging its tail. It's not drawing anything. We'll move over there. We'll set our direction. Now we'll go and put the pen down. Now it's ready to draw. Okay, let's give that a try. Okay, so that's looking like the proper version of our n equals 1 code. Now, right now, our code still needs some fixing, because what we've coded in is we said, if n equals 0, we get that. If n is anything else, we get this one here. And so right now, even if we put in n equals 2 or n equals 3 or n equals 5, it doesn't really matter what we put in. But if we put in any value of n other than 0, instead of giving us a line, it gives us that same shape, which would only be the right one for n equals 1. So we've still got some work to do here, okay? And if you get errors like this, don't worry about it. That's some bugs within TurtleGraphics. It's drawing things correctly. It's an old package written by the textbook author and hasn't been maintained. So let's see, what should we do? You know, if you want, this might be a good time to actually stop the video and think about what you would do here, and see if you can make this work for any case of n. We've made a base case of n equals 0. Our problem here is that we're saying no matter what, always do the same thing. Move this length, then make your turns and so forth. And what we really want is we want some connection between the nth and the nth plus 1 cases, or you could say between the nth and the nth minus 1 cases. We want to relate this somehow to the case that came before it. So instead of always moving the same distance, for example, it needs to move less and less distance each time. So it needs to refer to the one that came before it. Here's where the recursion comes in. So what I would recommend is take a moment and stop the video and see if you can get that. Okay, in fact, maybe I'll make a second video to finish up. Okay, so I'll be back in a minute.